So here we have a model for Olympic sprinters, runners. So it says careful measurements have been made of Olympic sprinters in the 100-meter dash. A quite realistic model is that the sprinter's velocity is given by the following expression. V is equal to A with times parentheses 1 minus e to the minus b t. E is the is 2.71 and so on, is the is Euler's number, 2.7 whatever. And then A is a constant and B is a constant. It says here for sprinter Carl Lewis in his sprint of 1987, he had the parameters A is equal to 11.81 meters per second. Notice A here is not the acceleration, it's just A, some parameter called A. And then B is 0.6887, and the units are 1/seconds. Because that's what it makes sense, because the velocity has to be in meters per second, so A times, if you FOIL this, you have A times 1, that's A. And so it has to have dimensions of velocity, of length over time. And here, e to the something, the time is in seconds, so B has to be in 1/seconds so that they cancel and you just have e to some number. Because it doesn't make sense to say e to a 7 meter, what's that? We know e to the 2, or e to the 7, or e to the 10, but not to some dimension, meters, for example. So the question is, first, what is Lewis's acceleration at time t equal to 2 seconds? At 0 seconds, at 4 seconds, at 0, at 2, and at 4 seconds. And then it says find an expression for the distance traveled at time t, and then we will solve that for time t. So remember, he's running 100 meters here, all right? So what is Lewis's initial velocity? Well, all runners, they better start at rest. So let's see if that checks out. 1 minus e to the, at time t equal to 0, you have e to the 0, a number to the 0 is 1, so you'll have 1 minus 1, that's 0, 0 times a is 0. So the velocity initially is 0. Looks good. And so we want to find the acceleration here. And so I will raise this board and then just rewrite the expression of velocity here. So we have the following. We have the velocity. I'm doing part A here. The velocity is a times 1 minus e to the minus b times t. And so the acceleration, since unfortunately they have used the letter A for acceleration, I'm going to use letter capital A for the acceleration. I will just write capital A for acceleration. So acceleration will be dv dt. Normally we will write for acceleration, this is acceleration. Normally we will use the lowercase a, but they have used it here, they have used that letter. So it's dv dt, okay. Well, let's take the derivative of this. This is a constant, so it will just stay there. And then I'll take the derivative here. What's the derivative of 1? Derivative of 1 is 0, or minus. What's the derivative of e to the something? Well, remember, if you have ddx of e to the x, it's just e to the x. And if you have ddx of e to the some constant k times x, by the chain rule, you will get e to the kx, that's the derivative of e to the something, but then the chain rule says you have to take the derivative of the inside function, so that gives you k. Derivative of kx with respect to x is k. It just gives you that. So the same thing here, when you take the derivative, you will have e to the minus b times t, but then you have to take the derivative of the top with respect to t. Derivative of negative bt with respect to t will give you minus b. So you have a minus b come down, a minus b. And so this becomes, minus times minus is plus, and it's just plus, just b. And then a times b, that's ab. And then e to the minus b times t. That is the acceleration as a function of time. So what's the acceleration of time t equal to 0? Well, at time t equal to 0, you will just have a times b and then e to the 0. Right? At t equal to 0. And so it is just a times b. And what is a and what's b? Let's scroll this down. A is 1181 and b is 0.6887. 11.81. So it's 11.81 times 0.6887. I will just write down the answer. I have it here. So at t equal to 0, it will be, when you multiply those numbers, you get 8.134. 8.134 meters per second squared. And then if you substitute 2 seconds, you will get a times b times e to the minus b times 2 times 2. You substitute 2 for t, and I will not. You should verify it yourself. Just substitute this. Well, a times b is 8.134, so it will be 8.134 e to the minus b, but minus b is 0.6887 times 2. And if you do that, you get a smaller number here for acceleration. Let's see what we get. 2.052. 2.052 meters per second squared. And then for the acceleration of 4 seconds, well, it will be just exactly like this, but with a 4 here. So it will decrease further. And so it's 0.5175. 0.5175 meters per second squared. That's the acceleration at 4 seconds. So this is the acceleration as a function of time. Okay? And so again, here is, so we don't lose sight. Here is the line. This is 100. This is 0. The runner starts here. And then the runner ends here. Okay. So initially, v initial is 0. X initial is also 0. Okay. So the next question here says, find an expression for the distance traveled at time t. So they want x. Okay, let's remind ourselves that this is just part B now. Part B. Let me just write down. So V, I will copy that expression again. V is A times 1 minus e to the minus b times t. Okay, b times t. And I'm going to FOIL this for a reason. You will see it. A times 1 is A, and then minus A e to the minus b times t. B times t. That's the velocity as a function of time. But velocity is dx dt, so I know that dx dt is equal to a minus a e to the minus b times t. And I would like to get x, I have to integrate both sides. So the integral of this will just give me x plus a constant. The constant, I will just banish it to the end here, plus a constant. And then for this, let's integrate it. The integral of a with respect to t is at. Because when you take derivative, the t goes away and you just have the a back. And then what's the integral of this? Remember, when you take the derivative, a minus b comes down. So when you integrate, you have to divide by a minus b. So it would be minus a over minus b e to the minus b times t. To verify it, take the derivative. When you take the derivative of this, a minus b comes down, and so minus b cancels the minus b on top, on the bottom, and you have the same expression here. And so I have x will equal to a times t. Minus over minus is plus. So I have a over b e to the minus b times t plus a constant. Plus a constant. How am I going to determine that constant? Well, I know that at time t equal to 0, x was 0. So x at 0 should give me 0. Let's substitute 0 here. Well, a times 0 will give me 0. And then I have here a over b. And then e to the minus b times 0, that's e to the 0, which is 1. So it's just a plus b, a over b plus the constant, Therefore, therefore this constant here, this c, so a over b plus c is equal to 0. Therefore, c will give me minus a over b. So I will go back to here and substitute minus a over b for the constant c. So I get the following. I get x is equal to a times t, plus a over b e to the minus bt, plus a over b e to the minus b times t, plus the constant c, but c is negative a over b, minus a over b for that constant c. And so I get so that is x. That's x as a function of time. You could make it look prettier if you like. You could just factor the a over b outside. So you can say a is, if I take an a over b outside, what's left? If you take an a over b here, so you will have the t is left and you have a b here. Because when you multiply it back, b on bottom, 1 over b times b is gone and you just have at back. Yeah, so that's good. If you take an a over b here, you will just have the e to the minus b times t. And if you take a over b here, you just have minus 1 left. And that looks good. Yeah, that looks good. And so now I'm going to substitute the numbers. What was a again? A was 11.81. A was 11.81 and B was 0.6887. So I have 11.81 over 0.6887 times B times T. So 0.6887 times T plus e to the minus 0.6887 times t, and minus 1. Just one more step. 11.87 over 0.6887 gives me 17.15. So x is 17.15 times 0.6887 times t plus e to the minus 0.6887 times t minus 1. All right, that's the expression for x. So now if I ask you to, how much time will it take for x to be 100? So if I substitute 100 on the left side, if I substitute 100 for x, what's t? So you have to solve for t. The problem is this is not a simple equation to solve. It's called a transcendental equation, meaning you can't solve for t. You have to solve it numerically. You have to do a trial and error. So for example, a runner usually takes about 10 seconds or so to complete the run. So you plug in t equal to 10. If 10 seconds gives you over 100, then you try slightly less. So by trial and error, you can get like t is 9.92. Or you can solve it numerically. And I want to show you how to solve this numerically using the web. All right, so give me 1 second. I'm going to pause this and show you how to do it using Wolfram Alpha. So welcome back. I have now turned on my computer, and for reference, I wrote down the equation here that we would like to solve. We have this equation. X is 17.5 times the stuff in parentheses, and the stuff in parentheses is 0.6887t plus e to the minus 0.6887t minus 1, and we would like to figure out what t is when x is equal to 100. And for some reason, the projector here is blurry. Let me see if I can do anything about that. Okay, my apologies to you. For some reason, the projector wasn't focusing, so I decided to just record my computer screen here directly. So first of all, I will go to Wolfram Alpha. Wolfram Alpha. So if you just use Google Wolfram Alpha here, it just gives you something, and you get this. If you may be familiar with it already. So on the board, I have x equals to 17.15 times parentheses some stuff. So I was just so I say solve. I want to solve that equation for x equal to 100. So I put solve the following expression: 17.15 times 0.6887t, and then plus e to the something. E is exponential, minus to the negative 0.6887t, and then minus 1. This is x, and I want to solve this for x equal to 100. All you have to do is hit enter, and it will solve it for you. So just scroll down, and let's see what we get. And I think I'm having trouble here also. No, okay, it solved it. So it says t equals to 9.91698, or t equal to negative something. We want the positive time because the person started running at t equal to 0, and the time goes forward. So it's about 9.92. You can also do it by trial and error. And so that's that for this particular problem. By the way, for this, you can use it to solve pretty much anything. Solve, for example, like a quadratic equation. Let's say you have this quadratic equation here, and I want to solve x. Let's say I have this quadratic equation here. I want to solve it. So it solves it. It gives me some numbers here. In this case, the quadratic equation gave me some complex numbers. Let me try to get maybe something that's not complex. Let me change the sign here. Maybe it will give me some real numbers. No, nope, still that. Let me make it positive 1. Okay, so now I have some real numbers. Here are the results. 2 negative radical 3 or this. If you like, you can view it will graph for you the equation, and that's where it crosses the x-axis. You can put approximate form. Approximate form will give you not the exact result, but approximately. It's 0.26. So that's 0.26 and 3.7 something. So 3.7 something is here. You can use it to solve cubic, logarithmic, whatever. You can plot things. For example, plot. Oh, they suggest something for me. Here is plot this equation. Okay, so that's the plot for this function. You can plot, for example, sine of x, and so on. All right, I think you get the idea. I would suggest you play with it. I think it's a good program to have in addition to your calculator. Obviously, in tests and so on, you don't have access to it, but in general, at home, you have access to it. All right, and I would see you next time doing vectors.